Good morning, student. Today I am going to explain the important concept. This is the second unit of electronic instrumentation. In first unit, we have seen that the introduction to the instruments. So, instruments are before going to explain cathode ray oscilloscope instrument. First, let us revise Unit 1 concepts. Just 5 minutes. So the instruments are classified into two types: analog instruments and digital instruments. By measuring physical quantity like voltmeter, ammeter, voltage, voltmeter measures voltage, ammeter measures current, or the resistance measurement, the capacitance measurement. With the measurement of any physical quantity, errors are appear, and also we have seen errors classification, what is an error, how to remove error, eliminate errors, what is multimeter, what are the functions of multimeters, what is the basic principle involved in analog multimeter and digital multimeters, and also how to determine voltage, resistance, current, capacitance, AC current, DC current, AC voltage, DC voltage using the instruments like multimeter, and also applications of multimeter, the importance of voltmeter, ammeter, and also use of function. This is the unit 1 content. Very important. Now I am going to explain cathode ray oscilloscope, which is different from the multimeter, voltmeter, ammeter. Generally, multimeter, voltmeter, ammeter representations, ammeter instruments, we can measure only the values of physical quantities, values of only voltage value. For example, voltage measured by voltmeter. For example, 1 volt, 2 volt, 3 volt, only numerical values. We can measure only numerical values. But CRO is an electronic instrument which provides the visual representation of the variables. So, visual representation of the variables. If we connect the output of the circuit to this CRO generates waveform which is available in its fluorescent screen, by which we can measure voltage, current, amplitude, time period, frequency, etc. variables. This is a very important electronic instrument used in almost all industrial applications. Different types of CROs available: welding CRO, laboratory CROs, basic CROs, etc. Because there are a lot of applications in various fields. So the CROs are used to measure AC current, DC current. CROs are used to measure AC, DC voltages, and also used to measure frequency, time period, and also used in hysteresis loop tracer, and used in radios, television, communications. So everywhere we can use CROs. One of the important electronic instrumentation. So we are going to see in this class what is the basic principle of CRO and the black diagram of CRO and the representation of importance of cathode ray tube. Let us see, the title of the concept is cathode ray oscilloscope. Cathode ray oscilloscope. So in this cathode ray oscilloscope, if you see the black diagram of the cathode ray oscilloscope, this is an input from the circuit which is connected to a vertical amplifier circuit. Connected to vertical amplifier circuit. The output of the vertical amplifier circuit further connected to a delay-like circuit. So here, the output of the vertical amplifier is divided, split into two parts. One of the output is connected to delay-like circuit, and the second output is connected to a time-based generator circuit. Time-based generator circuit. Here the pulse is split into different time zones. The output of the time-based generator is connected to horizontal shift horizontal amplifier. And the main important part of the cathode ray black diagram is CRO. This is the main part of the cathode ray oscilloscope. So this cathode ray tube CRT consists three stages. One is electron gun, which produce electrons. Electron gun. The second stage of the cathode ray tube is magnet deflection system. Deflection system. Here the electrons are moved in unidirections with the desired velocity. The last stage of the cathode ray oscilloscope is a fluorescent screen. Here we can observe a waveform of physical variables by which we can measure all voltage, all parameters like voltage, current, amplitude, frequency, time period, etc. So the output of the horizontal amplifier, which is connected to two horizontal relays, and the vertical and linear lines and vertical amplifier circuit is connected to two vertical relays. Two vertical relays. And the CRT is connected to high voltage supply, and for remaining circuit we can provide a low voltage supply. So if you see the main parts, essentially this CRO consists input, vertical amplifier, linear line circuit, time-based generator, horizontal amplifier circuit, and cathode ray tube. So here the waveform we can observe the fluorescent screen. So if you see the various controls of CRO has number of switches, indicators, control system units. So CRO have vertical shift control, horizontal shift control, time-based generator circuit, and also intensity control, focus control, and used in different channels. These are the various controls of CRO. So basically, the main function of the cathode ray oscilloscope is cathode ray tube. So this cathode ray tube is used to produce the electron beam on x-y directions. So an x-axis generally produce waveform, an x-axis time period, along x-axis we can put time period, y-axis voltage, z is the representation of the intensity, z is the representation of intensity. So intensity, time period, or voltage control. So ultimately the waveform of the cathode ray oscilloscope is observed in a two-dimensional representation by which we can measure voltage, current, etc. Now see how to measure voltage, current, amplitude, wavelength, time period, frequency by using cathode ray oscilloscope. Let us see. If this is the fluorescent screen, the fluorescent screen it is in a rectangular shape, has number of vertical lines and horizontal lines. So this is the representation of the fluorescent screen. This is the fluorescent screen. Here each unit further has 4 subdivisions. Each subdivision value is 0.2 centimeters. If suppose there is a sine wave appears on this fluorescent screen, so by which the wavelength lambda can be measured, time period can be measured, amplitude, frequency also measured using this waveform. See how to measure wavelength. So for the measurement of wavelength, let us take an x-axis. The distance between two successive peaks is known as a wavelength. Wavelength usually measured in centimeters. At this situation, so depending upon the situations, wavelength measured in centimeters, meters, angstroms. But here is CRO representations. The wavelength can be measured in centimeters. So let us take the distance between two successive peaks. General definition to the distance between two successive crest or cuff. Here in wavelength can be measured between two successive peaks. Suppose here the wavelength 1, 2, 3, for example 2.5 centimeters. It is only an x-axis representation. Amplitude represents the displacement of the wave along the y direction. amplitude. In order to measure amplitude, count the number of vertical lines along the y-axis. Here the amplitude of the wave is 3.2, approximately 3.2 centimeter at this situation. And also the time per unit cathode oscilloscope, we have time-based Hilbert circuit, which is available in three different scales. One is available at second scale, and second milliseconds and microsecond scale. Therefore, for convenience and simplicity, let us take time per division value is 1 millisecond. Then the total time period, capital T, can be mathematically expressed as wavelength into time per division value. So therefore, here the wavelength is 2.5 centimeters, and time per division value for the mathematical simplicity, let us say 1 millisecond. Therefore, 2.5 milliseconds. As you know that the reciprocal of time period is known as frequency. So the frequency is defined as 1 by time period. Now therefore 1 by 2.5 milliseconds. So frequency is expressed in hertz. 1 hertz is known as 1 cycle per second. This is the unit of the frequency. And therefore 2.5 milliseconds is the value of the frequency. So here in denominator we have milliseconds. In order to convert in the hertz or kilohertz, the frequency is equal to 1 by 2.5 into kilohertz. So denominator we have milli. If you multiply with kilo and divided by kilo, denominator kilo and milli cancel. Bases are equal. Then powers are sum. Then 1 by 2.5 kilohertz. This is the measurement of frequency in cathode oscilloscope representations. So for example, if CRO displays a triangular wave, then display triangular wave, sine wave, cosine wave, square wave, pulse wave. So almost all waves can be displayed on a cathode oscilloscope. So we can measure all these physical quantities, wavelength, amplitude, frequency, etc. For example, if in CRO in cathode oscilloscope we generate a square wave representation. If you see the square wave representation, it is little bit difficult when compared to sine wave, cosine wave, and triangular. Sine, cosine, and triangular representation, it is very easy to represent amplitude, wavelength, time period, frequency. Once if you define time period wavelength, it is very easy to construct frequency, because the reciprocal of time period is simply defined as a frequency. Now therefore, if cathode oscilloscope generates a triangular wave, basically the square waveform. Basically the square waveform can be generated by charging and discharging of capacitors. This is the basic principle of square waveform generator. So by discharging the time, it is saturated, then again charged and saturated, discharging the capacitance, again saturated and charging the capacitance. So based on the charging and discharging of capacitance, the square waveform generated in a cathode oscilloscope. Here the wavelength can be defined as, the wavelength is defined as the distance between two successive charging peaks or two successive discharging peaks. If suppose here in this display fluorescent screen, this is the discharging peak. If you want to measure wavelength of square waveform, so find the distance between either between two discharging peaks. This is the discharging peak. So this is the wavelength of the square waveform. Or find the distance between two charging peaks. So this is the charging peak. So either find the distance between two discharging or charging. So once if you define wavelength, find the time period. The reciprocal of time period is frequency. So in this way, you can define time period, amplitude, frequency. Now how to define the voltage? Generally, in a CRO we have a voltage based circuit, volts per division circuit system. Volts per division also available in two different scales, at two different scales. One is millivolt, other one is volt scale. For example, for simplicity, in theoretical approach, if you take volts per division value is 1 volt, simply multiply volts per division value into amplitude defines voltage. So voltage is defined as amplitude into volts per division value. In our laboratory, we have three important experiments. One is the measurement of voltage, resistance, capacitance, current using multimeter. Other one is the measurement of voltage, resistance, capacitance, current using CRO. Third one is the measurement of voltage, current, resistance using a function generator. However, once you define voltage, frequency, current, compare these values with the multimeter. Multimeter is the ultimate electronic instrument, measures the voltage, current at different states, which can perform multiple operations. Ultimately, the output of the cathode oscilloscope is compared with the multimeter readings. This is about briefly about the cathode oscilloscope.